Hey guys, so I'm going to do this example to find the pH of a buffer solution. So we have 0.06 molar HF and 1.0 molar KF. So first thing I need to do is I need to write the reaction. I recognize this as the acid. So I write HF, and I know that it's going to dissociate into H plus and F minus. Okay, so then I put my initials, and my other initial is my 1.0 molar KF. We do not care about the K because it's in group 1. Anything group 1, group 2, or chlorine, bromine, iodine, we don't care about. Okay, so next thing that's going to happen is I know the F is going to dissociate a little bit, so I will lose, the HF is going to, so I'll lose some there, but I'm going to add some here and add some here. This should be 0. Okay, so now we have 0.6 minus X, I have X, and I have 1.0 plus X. We can neglect because 5%. You do need to write out 5% rule. You need to write out all of that every single time you do it. Okay, from here we know that the Ka is equal to the concentration of F minus H plus over HF. So we substitute. I know that the Ka for this is, I think it's 7.2 times 10 to the negative fourth. And I know that that is now equal to 1 on top. The unknown is the H plus, and 0.6 on bottom. When you solve for H plus, you would find that it equals to 4.3 times 10 to the negative fourth. And let's check our assumption. Is that much less than 0.06 or 0.6 and 1.0? Yes, that's good. And to find the pH, we just take the negative log of that, so we would get pH equals 3.37, which makes sense because it is a weak acid, so it doesn't have quite as much pH, and it has this F in here. It's a buffer solution. Okay, now in the next podcast I'm going to show you what happens when we add something to this buffer solution.